Welcome viewers. In this video we will see the details about the encoders in the digital electronics. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic encoder. An encoder is a digital circuit that performs the inverse operation of a decoder. So we see what is encoder, what is decoder. An encoder is a 2 to the power n input lines and n output lines. 2 to the power n inputs and n outputs. In case of decoder means n input lines and 2 to the power n output lines. Both are inverse. The encoder, in encoder the output line generate the binary codes corresponding to the input value. Based on the input value, the binary codes are generated as a output. The diagram shows the general structure of the encoder circuit. As shown in the diagram, the decoded information is presented as 2 to the power n input producing the possible outputs. Now we'll see the block diagram. So this is the block diagram of the encoder. 2 to the power n inputs, n outputs. So these are the possible 2 to the power n input lines. 2 to the power n input line. This is a possible n data output lines. This is a enable input. If the enable is 1, the decoder is enabled. It will give the output based on the input. If enable is 0, it is disabled. It will not produce any output. In order to enable or disable, we are having enable input. Now we'll see the one example. 2 to the power n inputs and n outputs. Let us consider n equal to 2. So 2 to the power 2 is to 2. That is 4 is to 2. That means 4 inputs and 2 outputs. 2 digits. 4 digit input and 2 digit output. How it is producing? So this 2 digit output is based on the input. Let us consider the inputs y3, y2, y1, y0, 4 digits. Then the output a1, a0, right? So we know that this 2 digits mean there are 4 possibilities: 0, 0, 0, 1, 1, 0, 1, 1. So these are all the 4 possibilities. We know that 2 digit, 2 to the power 2, 4 possible outputs are there. Now we'll see how we are getting these 4 possible outputs. For the first case, if y0 is 1 and other digits are 0, then we'll get the 0, 0 as the output. If y1 is 1, other digits are 0, then we'll get the next possible output 0, 1. If y2 is 1, other digits are 0, we'll get the next possible 1, 0. If y3 is 1, other digits are 0, then we'll get the fourth possible output 1, 1, right? So the value of y0, y1, y2, y3 will decide the 4 different possible outputs, right? y0 is 1, other terms 0 means we got 0, 0. y1 is 1, other terms are 0 means 0, 1. y2 is 1, other terms are 0 means 1, 0. y3 is 1, other terms are 0 means 1, 1. So we are getting all 4 possible outputs, 2 digits, so 4 possible outputs based on this 4 values: y0, y1, y2 and y3. So from this we can develop the logical expression that can be implemented with the logic gate. For example, these two are 1. For a1, these two. What is this? y2 and y3 is higher. So a1 is nothing but y2 plus y3. y2 plus y3 mean we need one OR gate. y2 and y3 will be added, so that we'll get the a1 output. For a0, these two are 1s, second and fourth. What is the corresponding input here? y1. For this one, it is y3. So we need to add y1 and y3. y1 plus y3. So we need one more OR gate. By connecting y1 and y3, we'll get the output a0, right? So logical expression for this is y2 plus y3. Here y1 plus y3. That can be implemented with the OR gate, so that we'll get the required output, 2 digit output. So So in this video we discuss the details about the encoder, 2 to the power n inputs with n outputs. Now we discuss with one example also. If n equal to 2, there are 4 inputs and 2 possible output, that also verified. And we discuss how to develop the logical expression and how to implement the logical diagram also. More videos available about the encoders. The details are given in the description box. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.